This relates to problem number 9. F of x is x squared, so we make a table and a graph for f of x equals x squared. Here's the table, here's the graph, here are the graph points. And we all know how to do that, and we can all do that quickly. Okay, then we make the table for y equals f of x plus 7, and with this restriction that we're going to need to manipulate our x values so we get the same y values that we got here. Okay, so, well, what's f of x plus 7? Well, f of x is x squared, so f of x plus 7 is x plus 7 quantity squared. Now, let me kind of erase the conclusions here. Okay, we want to then start with our y versus x table for this function using the same y values that we had up here. Now, I don't want you to do it, but I eliminated the plus 1/2 and the minus 1/2 just for time, because snow schedule today, we were a little bit pressed for time. I didn't want to get into that. And maybe I wouldn't have anyhow, because I want to make this as clear as possible. Okay, so we have y equal to 4. Okay, well, for what value of x would f of x plus 7 give us 4? Well, f of x plus 7 is x plus 7 squared. So what value of x, what value would you have to square? What value of x would you have to put in here so that when you square x plus 7, you get 4? Well, you can think about it for a little bit, but it turns out that, well, if x was equal to -5, then -5 and 7 would be 2. And when you square that, you would get 4, wouldn't you? So 2 would be a or -5 would be a possible value of x that would give you 4. But there's going to be 2 values actually, and the other value would be -9, because -9 and 7 is -2, and when you square -2, you get 4. So we have 2 possible values that we can figure out maybe by thinking about it, or maybe we could write out the equation. X plus 7 squared equals 4. So by something we talked about the other day, x plus 7 is plus or minus the square root of 4, which is plus or minus 2. Well, if x plus 7 equals 2, then x equals 2 minus 7, which is -5. And if x plus 7 equals -2, then x is -2 minus -7, which is -9. Now, you can easily figure that out, but it might not be necessary to go to this. You just keep trying different numbers, and eventually you're going to at least, you're going to conclude that x could be -5. You might forget to conclude that x could also be -9. So I'll remind you of that. Well, okay, now, we probably want our x values to be increasing as we go from here to here. So I'm going to put -9 here and -5 here. When x is -9, we get 4. When x is -5, we get 4. Okay? Now, similarly, if x is -8 or -6, x plus 7 squared is going to be 1. You can check that out. If you've got these numbers, if you understand these, you'll understand how we could easily enough get these. Looks like we got a hole in here. We could put a -7, right? And then we have consecutive numbers. And that's clear because in order for x plus 7 squared to be 0, x plus 7 has to be 0. And for x plus 7 to be 0, x has to be -7. So we can conclude this. Now, what does this show us about the graph of x plus 7 quantity squared? Well, it means that we got to go all the way over to -9. So I think I counted right, 1, 2, 3, 4, 5, 6, 7, 8, yep, -9, before we can go up to y equals 4. So we're going to have a point here. And let me make that point clear. -8 gives us 1, well here's -8, here's 1. -7 gives us 0 here. -6 gives us 1. -5 gives us 4. Now and then of course the graph is here. Now, what happened is that by replacing x by x plus 7, it appears that we shifted the vertex over 7 units. Okay? And it looks like, let's see, we had the point -1, 1, and it looks like that point shifted -7 units in the horizontal direction. It looks like the point -2, 4 shifted -7 units. And these points over here shifted -7 units. In other words, the whole blame graph shifted 7 units to the left when we replaced x by x plus 7. So the whole graph shifted -7 units because in order to get the same y values, x has to be 7 less than it was up here. Now that's worth pondering and worth understanding. I'm thinking, I don't think I have any more here. Oh yeah, I did that in the MCR. Okay, just to relate this, here's our x squared graph. Okay, our graph of the water depth versus time typically might be out here someplace. Have a vertex way over here. And be a more flattened parabola. Now the way you drew it, it probably isn't, that doesn't look that flattened, but that just depends on what scale you use for the x and the y. On the scale of this graph, the parabola would be quite flattened, and we'll see how that works later. The thing I want you to understand, though, is that if we can flatten this graph, okay, if we squash it down to make it a lot flatter, then it could have the same shape as this one, at least the left-hand part, the part from the vertex over to the left, the part that corresponds to the domain of the flow function. Then we can replace x by, well, it'd be x minus some number to shift the graph over this way. And then we can add some number to that function to shift the graph up this way so that the vertex goes over here to where it's right below this vertex, goes up here. So if we can flatten this graph and then shift it over using something like this and then shift it up, we can match the graph of our flow function. And that's actually quite a big deal, the ability to manipulate graphs and the ability to construct graphs from the basic functions, and that's what we're leading toward.